A large part of what I'm going to focus on today is a problem-solving framework. Engineering solutions frequently give rise to further problems. We see that in sort of like the design of a car or planes, giving rise to a new problem, giving rise to a new solution. So, I've got a task for you. I got an email a few years ago from the tax office. Should I click on complete formula to get my tax return? But to get there, I'm going to get you to do a little process. Positive indicators. Why would you believe this email? Negative indicators. Why would you not believe that email? So you've got 2 minutes to come up with 2 lists, at least a few items on each.
Looks like a credible email address. It had the correct government seal for the ATO.
Message ID.
The undisclosed recipients was a negative because it's clearly actually been sent to more than just you. The grammar mistakes.
Is an internal discrepancy. Undisclosed recipients all getting the same amount just doesn't work. So when you find internal discrepancies, when you're an engineer, like say reading reports that Colin wrote, if his supervisor is saying, hang on, this information doesn't marry with this information, you know, there's something not right here. That's the sort of activity you've got to engage in all the time. You can't believe things just because an engineer said it, or is published, or is peer-reviewed. That's only the first layer of assurance. You've got to be much more discerning than that. The whole point of this activity is, what skills did you use? Discussion? Yep. Listening?
Critical analysis.
Yep. Critical analysis.
Looking closely and comparing to what we know and...
Oh, okay, that's a good word. Cross-reference. 2 lists. That's completely different from 1 list.
Oh, wow.
And you might think that was a joke, but I'll tell you how when you make 1 list, what happens. You cut and paste from articles or the web and dump it into assignment. You highlight things or you copy things indirectly, and you become victims of information. If you create lists where you've got this or that and you have to make decisions, you become masters of the information. And that's what you have to do. You have to have organisational structures that actually don't enable you to be a victim, but you have to take control of information. So what I'm going to show you is that what you're demonstrating is the skills connected to problem solving. Yeah, optimising problem solving. So how do you get the best solution given all the different people, all the different costs, all the different time factors, all the different documentation? How do we have an optimal problem solving? First of all, you have to begin, you have to define the problem. To know what it is after and be really specific or specifying the parameters of the problem. When we think we know what we're after, we have to find information that's relevant. Does this fit into my previous understanding? Does this work compared to the sort of work I've done? Then we have to generate often ideas ourselves, things that relate to the problem or the device that we're working on. And evaluate is the process where you are not gullible consumers, but you're discerning users of information. You've got others, sources, your ideas, you've got to organise them in ways that are appropriate. Sometimes that's text and 2 lists. Sometimes it's graphs and tables. Sometimes it's diagrams. Organisational structure visually is absolutely pivotal in most aspects of engineering. And manage the process. So if that's individual, you have to think of your time management. The self-management is critical, as well as the team management. But when we've got things that are organised, then we can do a comprehensive analysis. As people said, it's breaking it down into its parts to analyse it, and often it's also looking for the trends in the data as well. It's both the little bits and the big bits, and how they all come together and make sense. And the synthesis, putting everything together so that it begins to make sense for yourselves as you work through.
Design model.
Yes.
I mean, the process that you go through in designing a product is almost identical
Yes.
to this in every way.
To communicate is, yes, an end product, reports, manuals, maintenance, final assignments, but more than anything, it's a process from beginning to end. What do I do? I'm not sure what to do. Asking questions, probing, talking, it's how all the other things come together. So it's called optimising problem solving. Define and specify a problem, find and reflect, generate and evaluate, organise and manage, analyse and synthesise, communicate and apply. So they're the 6 different skill sets that you showed me back in that previous slide. They're the skills that you already have. So why are you at university? Why are you studying first year mechanical engineering if you've got those skills? Well, you need to develop them in an engineering context. Those are very general, like applied to scams. You've got some great skills. You need to apply them with engineering specific terminology, engineering specific thinking, and you need to see that skill set develop, mature, get richer and richer, so that over the years, what happens is you see them become more and more sophisticated. When you're not sure what to do, go back to what your problem is. Go back to your starting point, or even sometimes the question. What your client wants. What are we supposed to do here? When you get stuck and you're wandering around, go back to the centre and make sure that your problem is defined and specified. It may be that you've done that, but actually it's not clear enough. Or you've actually specified it in the wrong terms. Or you just need to be think, oh, that's right, that's what we're doing. I forgot. Go back to the centre every time. I'm going to give you a minute to identify as many of those skills in the ops as you can. But just brief summary, they were dying because they were producing carbon dioxide and there's no filters to scrub out the carbon dioxide. So these dudes had to use that equipment to make a round filter fit into a square hole. What's an example of one of those skill sets that they were using?
They defined and specified the problem.
What did they have to do with that problem next? That was the overarching problem. They didn't want them to die, that's for sure. So what was the sub-problem that they faced next? Yeah, square peg in a round hole. So problems are like that, aren't they? There's often the big picture, this is the problem, they're going to die. There might be multiple solutions, but this is the one we can do in the time frame. So optimally, we've only got minutes or a couple of hours, and then how can we do that? Yeah. In fact, wasn't it communicate heavy?
They analysed and synthesised in listing the things that they had available and then determining how they could use those to fix the problem.
Yes, you need to see these same skill sets in varying contexts. So these are the skills that we saw from ops. What you need them is to develop richly throughout your first year, including this course. You need to see them develop and grow so that by the time you're a graduate, ready to go to employment, you've got a sophisticated, fine-tuned skill set. So Einstein said, out of plunder find simplicity. One of your hard tasks with communication is not how many thousand words, like 8 pages, but how do I say this as simply as possible to get rid of all the crud? So, whilst communication has very different guises, you'll be wanting to make great engineering products, but remember, communication is an absolutely essential part of that process. Thank you.